Welcome guys, this is your instructor Rahul Shetty. So in this video, let's see top Python Pytest interview questions with clear-cut explanations. Okay, so without making much delay, let's get started to our first question. What is the difference between list and tuple in Python? Okay, so let's try to see what exactly the difference is. So one prime difference what people will tell when they ask about list and tuple is that lists are mutable where tuple is immutable. So this is how people theoretically answer if they just gone through interview questions anywhere. But if you get a counter question, explain how they are mutable and immutable, that's where your real programming skills plays a role. So let's see what is the list first of all. So let me create a simple list. My list equals to, you should have a squared bracket like this. Okay, so to keep it simple, if you are aware of Java, it's kind of array. Okay, in Java or JavaScript we call it as an array, and in Python we call it as a list. It stores a collection of elements. So I will write 3 items here, 1, 2, 3. So these are the 3 indexes going inside this list. Okay, now if I want to modify the list, right, I can do it very easily. That I can just say on 0 index. Right now this is 0 index, this is first index, and this is second index. If I want to update this 0 index with a new value, I can just say 100. It's still fine. Now when I print this, it will print me the updated list. So that means lists are mutable, means they can be updated, modified, or changed. Okay, so let me quickly run this test and you see 102, 3. Okay, that's a list. Tuple, that is also one of the data type in Python, which exactly does the same, that it stores multiple elements into its box. Now let me create a tuple. My tuple equals to, but instead of square bracket you should have a brackets like this. Okay, so this is the convention of tuple. And again, right, you can write the values what you want to see inside this tuple. So there are 3 items inside this. Now you can access them again in the same way. My tuple of 0 you can be accessed, but the problem here is you cannot modify because tuples are immutable. So when you try to actually update the way we did in the previously for list, that 0 equals to 100, and when you try to print here itself, it is actually telling you the error. Okay, so let me print it in the output. So however your cursor here, there is some mistake, right? Let's see what is that mistake. Okay, tuple object does not support item assignment because they are immutable. That means they cannot be changed, where in the list you can play around. Okay, so let's say you want to add another item at the end. How do you do that? Very simple. My list dot append. You can append any number. If you want to append 4, just append it. Or if you want to pop out, that means if you want to remove any index. So let's say I want to remove the first index. So this is my list. Okay, so this is the initial list. After this, how the list looks like? 100, because we are replacing 0 index with 100, right? 2, 3, and we added 4. This will be the list after this step, line number 7. Now, if I want to remove first index here, I would just say my list dot pop out the first index 1. 0 index, first index, 2 will be popped up. And now when you print list, you should see output as 100, 3, 4. Okay, let me comment out this because this is not allowed. Now here you go, 100, 3, 4. It exactly prints the way we want, and it just printed a tuple because we commented it out. So that's how you can tell the basic difference about list and tuples. Their definition conventions also differ. See, here we are exactly the brackets look like this, but here it is varies, right? That's about list and tuple. That first thing what people expect you to answer when they ask about difference between these 2 data types. Okay, next, what are Python's built-in data types? So just now we have seen list and tuple. But what else you have in Python? So that is one of the common question you get when you are talking about list and tuple answer. If you failed or struggle to answer this question, then they will root back to the basics. Like, can you explain me data types? Okay, very quick. So we have something called integer in Python, which declares like this, takes a number. We have something called float, which take a decimal value, right? So you should be knowing this. These are basic things, right? And you see in list, tuple, and there is something called dictionary. This is very important. So people expect you to tell this word dictionary. So it takes like a key value pair, just like a JSON. It will have a key and then value. So value of 1 will be assigned to this key. That's how dictionary. It's a collection of key value pairs. And obviously there is something called string where you can pass the string values, and there is something called boolean. So these are like top, and of course all the data types what it supports, and list and Python. So all these are the supported Python built-in data types, and most of the interviews will be heavily on list, tuple and dictionaries. The questions will revolve on these three data types to check your basics. How do you implement inheritance and super keyword in Python? Okay, the gears have shifted to object-oriented principles now. So once you are a good understanding of the data types, the next question obviously will be shifted to OOPS concepts. Okay, how do you implement inheritance? So first of all, what is inheritance? So basically acquiring properties of parent class into child class is what we call as an inheritance. Now let's see with one simple example. I declare a parent class like this, and this parent class have a method called greet, right? So self keyword is by default have taken as a first argument to any class method. More about this I will be talking very soon, because there is another interview question waiting for you on knowing what is self. Okay, so in this method I am just returning hello from parent. Great. So this is the method and this is the class. Similarly, let me have another class. I'll call it as a child class. So what I'll do is this child class will acquire the all properties by inheriting from its parent. To make that connection possible, you have to send parent class name as an argument to this child class name. That's it. If you send like this, then automatic connection is formed, and now this child class is inheriting from the parent class. Okay. Now even this class will have its own method. Now let's call it as hello greet, some method like this, and here return I would say hello from child class. Okay, great. Now let me create object of this child class. So how do you create object of any class? It's very simple. Call class name and then assign it to one variable, and now C is an object of this class which can access all the properties and methods. But because we are inheriting, that means we are accessing parent class also. We have access because we are using that inheritance concept. So C dot, when I do my own class methods I can call, I can also call my parent class methods also with child class object. So this is possible because of inheritance. Now if I remove this parent keyword here, and then you see immediately it is giving some gray mark here that this is not allowed. How can you call a method which does not belong to you? That's what it is complaining. But the moment I bring back that inheritance into picture of that connection, it is allowed. Okay, so like this, inheritance is basically used to inherit methods, attributes from another class, whatever class it is. Now, where does super keyword plays a role here? So super keyword is used to call parent methods or parent attributes within the child class. Now, let me do one thing. I'll make sure both the methods are same. So this is a parent class greet method. This is child class greet method. Now from here, I want to call parent class greet method. All I need to do is simply call this super method first. Super refers to the parent. Now on this dot, I would say greet. So this will make sure that this is calling the parent class greet method. Okay. So this is how super is used. So whenever if you want to access the parent class, attributes or methods, anything, use super keyword like this and dot call them. So you will be able to access. Okay, that's how super works, especially with inheritance. Okay, so that's why you will get a common question asking how inheritance and super keyword all connected, and you can explain them with this example, right? What is init in Python? So the init method is known as a constructor in object-oriented programming technology. So in the Python, init method is nothing but a constructor for a class. So now we have written two classes already here, but we don't have init method. If you don't explicitly declare init method, it will call default constructor. That means default init method will be executed in the backend. But if you can write something, that block will get executed when you create an object here in line number 13. Now in the same class, what I'll do is I'll create one constructor. So constructor can be done by calling this init method. You see that predefined. This is like already predefined method. And self is by default the first argument to any constructor or class methods in Python. Let's say I want to call a title. So title is an argument I have to send from my object creation. So just assume like this. And here what I can do, when you are creating object of child, because constructor is now expecting title as an argument, when you create object, you have to make sure you need to send the title, like Rahul Shetty Academy. This is the title. Okay, so if you don't have it here, then it is not required, because now we are not using default constructor. We are explicitly declaring the constructor. So this will be automatically invoked when you create object for your class. Okay, now things got little crazy. Now if you want to use the title here somewhere, then here where self keyword plays a role. Okay, self keyword is nothing but it's a class instance. Okay, now it has access everywhere within this class. Now this title is available here. So the scope of the title will be within this block only. If I want to use title somewhere here, I cannot use it because the title is a local to this block. Okay, and we can make it global by attaching it to the self, because self is a class instance. It will have access to everywhere in the class. So self dot title equals to title. So basically the title what you are getting, you are attaching it to the new variable, but this time you are attaching it to the self instance. So just because you assigned it here, this self will have access everywhere. Now you can call here also. You can say plus self dot title. So if you just write title, it won't have, it cannot detect, because this is local to this block only. But intelligently what we are doing is, when we collect that, we are assigning it to instance variable, so I can access it everywhere. So that's how self keyword plays a key role in moving things within class. If you are aware of Java or JavaScript, in their world you have a keyword called this. This is an operator we have used there. But in Python we have something called self. It's just the same way how it works in Java, this keyword, okay, which have access to entire class. So that means the constructor is not just used to initialize object. If it is just for initializing object, you don't need it at all. By default also it is initializing. The reason why we want to explicitly define constructor for classes is, if you want to send any argument values like this to the methods of the class, then we define a constructor like this, send a values, and from there using self instance we access those variables so that any method in that class can use. This is how all the connections form, and this is where you will see the importance of having constructor. I mean, you need to explain this. If you just say that constructor init method is known as a constructor to invoke an object, then even if you don't define, it will be called by default. Then what is the speciality of explicitly calling it? Then you can talk about parameterized. This is called parameterized constructor when you send a parameters, so that parameters can be accessed to the class methods. All this you can discuss. How do you read and write files in Python? So this is very, very easy compared to any programming language, guys. So let me quickly create a Python file for that. So in Python, if you want to, let's say, write a file, that means open a file and write some content in that file. So you start like this with open is the function where first argument you will give that file name. In the sense, you need to exactly pass the path of that file where is present in your system, like C, users, documents, give the entire path. Here I'm just writing it file name. And if you want to write into this text file, then use W. This is a keyword which will help you to write inside that file. So take it as an object called F. Okay, so that means you are opening a file in a write mode and assigning that to an F object. So this is a file object, F dot, and you have something called write. So using a write method, you will be able to write anything inside this. Now when you say hello world, then hello world text, this complete sentence will be written inside this file. Very simple, right? You can open any file and write any content with Python using this open function and make it as a file object. Now let's say how you want to read from the file. Yes, again, very similar example. You will open this function. See, there are arguments. You need to give the file and which mode you want to open. Previously we have used write mode. Now you want to open, let's say, in the read mode. Then you will just give that file name first, test.txt. And now if your goal is to read and extract the content of the file, then R. Okay, this will help to read, and then using this F object, you will simply say f.read. So all the content present in that file will be read, and everything you can store in one variable. The whole content will just come in this variable, and you can just print this, print content. That's it. So all the content of the file will be seen in your output because we are reading it in a read mode. If you want to write back into it in a write mode, just remember this open function and you can do both read and write with the help of Python with simple one line of code. That's the beauty of this language. What are fixtures in Pytest? A very, very important question. So let's try to understand with one simple example what fixtures are. Okay, but before that, how exactly you define it? Fixtures in Pytest are nothing but a functions. Okay, so but they are helpful in setting up test environments like teardown, setup. All those you can do in Pytest functions and inject them into your actual test. Okay, so if you have any test data, any setup before you run your test, and teardown, which you have to do it after your execution is complete, all those things you can write in one nice functions and then inject that function into your actual test. Okay, so with that we will see a lot of outcomes and positives in this. So let's try to understand with the code and then come back to see what are the outcomes from here. So this is a fixture. It became fixture because I put annotation called @pytest.fixture. The moment you put this annotation, it will be treated as a fixture. Okay, so what I am doing here, I am creating one dictionary. Remember, key value pairs are nothing but a dictionary data type in Python, right? So one dictionary object data I have initialized. In this case, test data you can assume, and then I am returning the test data. Fine, that's all. So this fixture is returning the dictionary of items. So now I am calling that fixture as an argument to my test. So basically this is my actual test. Okay, so the fixture I am sending as an argument to this test. So what happens by sending like this is, when we run this test, first of all, this test will check whether there are any fixtures as an arguments. Yes, there is an fixture called sample data. Once the match is found, it will make sure that it executes first before even entering into this code. Okay, so before even running any code inside its function, first it will run the complete fixture. So because we are maintaining that data here and we are sending the data, after completing it run, what it is doing, we are ultimately returning the data. That means a dictionary that will be stored in this fixture. So that's why, because we are returning the dictionary here, the dictionary of name Alice, that's where we are putting asset. So dictionary of name Alice will be printed, and dictionary of age 30 will be printed. So that is how we will be able to access the test data by having a fixture in place as an argument to your actual test. Okay, the one thing what you need to remember is, before even running it, the whole fixture will run first, and here where smartly you can return anything that you can catch the test data and continue your execution. So here we just saw that it used for test dependencies, including setup. Now let's say you want to run your test, automation test, and you can write a code of invoking browser here, and you can return the browser, and you can catch the browser here and just say browser.get all the drivers, everything you can get initialized in the fixture on the top. Okay, so primarily it is used for setup configuration and test data configuration, as well as tear down configuration. That means at the end you close all the connections, right? So until now we have not seen how tear down works here. I just shown that fixture will be run as a prerequisite before running your actual test. Okay, so for that there is a keyword called yield. So there will be another question in the fixtures itself, that how do you use yield for WebDriver setup or any setup on tear down in Pytest. Okay, so let me tell you that now instead of return, I'll just write yield here. Okay, and then after the yield statements, I'll just mention print cleaning up test data. Right, now what happens? You run this test again. So you know that initially the moment it's a fixture as its argument, first it will run the fixture. Okay, but having yield statement here, what happens is it will pause until this line. Okay, yield data, it's nothing just like return data. It will return the data, but the moment it sees yield statements, the control will transfer from line number 8 to your test, and then it will continue to run your whole test. Once your complete code of your test function is executed, then control will start again from line number 8 and proceed to the next. So here where you can write all tear down stuff like cleaning the test data, closing the database connections, closing the files, everything. Okay, so that way this piece of the code which comes after yield statement is a tear down. The one which comes before yield statements is a setup. So instead of having separate functions for setup and tear down, you can club everything into one single function with a separation of yield keyword, and whole function you can mark it as a fixture and send that fixture as an argument to your actual test. That's all. All the test configurations what you want to handle, because you see now you need to get the test data of name and age inside this. You created a dictionary, everything in your fixture, and you are returning it. That is solved. And all pre-data setup you can handle before yield statements, that it will run first before it running the whole test. And then post code also, like tear down stuff, the whole execution is completed and then control goes back after yield statement. For all these things, there is one simple solution called fixtures. Now you read the definition. Fixtures in Pytest are nothing but a functions. Yes, but that setup test environment we can do that before running the test, and cleanup also we can do. Right? Like this, fixtures will help you to manage test dependencies, setup, tear down, and you can write reusable code also, right? Now, reusable code, I mean, you can write for setup and tear down, and for all the test cases, you can use same fixture, right? Instead of rewriting setup and tear down for every test function, declare as one fixture and reuse it for all the test functions. Okay, so like this, reusability is maintained, setup, tear down, you can restrict scope also per test, per class. And finally, the dependency injection, the way we injected that fixture into test function arguments. Like this, you can talk at least 5 minutes about Pytest fixtures, including yield statements. So this broke down into 2 interview questions, like how do you use yield and how do you use fixtures in general. So the reason I put here, how do you use yield for WebDriver? So here you can clearly tell that before yield statements, you can write all driver invocation, browser invocation, selection of browser, setting the implicit wait, everything there. But again, after yield statement, you can make driver.close, browser.close, or you can close database connections. Everything you can do in test automation within one fixture. That's how you can talk in terms of test automation WebDriver terminologies, right? How do you create a list of dictionaries in Python? This is interesting. Okay, let's try to understand this question by breaking down step by step. First, let's create a list and the items of that list should be dictionaries. So the reason why people will ask this question is because list of dictionaries is nothing but a JSON. So how are you able to access JSON files using Python? So you can access it by converting them into a list of dictionaries. So that is the knowledge people try to expect. So let's see this with a quick example. So I'll create another Python file here. Okay, so first of all, create a list. Later we will do with the dictionaries. So when you say list, I'll just create like this. This is a list, right? But I want a list of items. Obviously, you need to write multiple items in it. Previously, when we are seeing the first example, here the list of integers. Okay, because we have set of integers and we call as a list of integers. But now I want a list of dictionaries. So how do you define dictionary? Let's see another quick example. Dictionary is nothing but key value pairs where you write in curly braces. So name is one key value where you write any name, and then value, let's say age. Okay, this is one key, and then value will be 23. So 23 is the number, so I did not put in quotes. So key value pairs, all this together constitutes a dictionary. So a dictionary is called set of key value pairs. So now I want here a list of dictionaries. Okay, so that means this is one dictionary, right? That will go inside here, comma, list of, right? Another list, probably, same thing, but we can change name and age. That would be second item, Alice, and age is 21, right? So this is a list of 2 dictionaries is what we're gonna say here. Okay, that's how you define. But what is special about it? By looking at this, you can tell that the list of dictionary is nothing but this is a JSON structure. Okay, this is just like a JSON array. If you have any API response or any data look in a JSON, you can simply convert that JSON into list of dictionaries like this. Now, I want to access Alice. How would you access it? Print the second index name. How do you do that? Let's see. So you know how to access the list, right? Now, we already saw that 0th index, if you put 0th item will be retrieved. Now in my case, I want name of Alice. So basically this is a list. So in 0th index, this guy is stored. First dictionary is stored. In the first index, this dictionary is stored. But I am interested in this. I'll first access the first index. Data of 1. This will give me access to this whole piece. From this, what is this now? This got accessed. This is nothing but a dictionary. So in dictionary, if you want to really access name, you will say like this, dict name. Okay. Considering this as a dictionary, if you want to access Bob, then you will say dictionary of and you put a name. Now when you access list data of 1, this is retrieved. Dictionary is retrieved. From this, if you want to say of name, and then it will retrieve the Alice. Okay, and then you can print it in the output. All right, let me comment out this code and let's run this test. And here you go. You see Alice is printed in the output. Okay, so they might give you JSON like this. Simple. They won't tell you that it's a list or dictionary, and they'll just ask you, consider this is a Python object. Okay, how do you access name? Simple. Look this in with the lens of Python data types. First, by looking at this, consider it as the list and see what are items present in dictionary, and slowly break down that, accessing the list second index, from that accessing the dictionary. Like that you can frame and show them that how you can access any element inside the JSON if it is shown as Python object like this, right? Next, what is Lambda in Python and how it is applied to map and filter functions? This is interesting. A Lambda function in Python is nothing but a small anonymous function. Anonymous function means a function which does not have any name. So this Lambda function can have multiple arguments, but only one expression. So theoretically, it is written in one single line. A Lambda function should be written in one single line, and you can send multiple arguments to that function. Obviously, there should be only one expression, one line of code in that function, because Lambda will be written in single line. Okay, let's see practically so you understand it better. So first let me show a traditional function, simple add function, x comma y. Okay, so this function will add x and y and it return it. Okay, x plus y. This is clear, right? Add function which takes two arguments and then it return it by summing up. Now, how to convert this as a Lambda function? Because this is best example, as it has only one expression. Whenever any function like this, you see that it has only one expression, then you can make it in single line using Lambda. So first Lambda, you need to write a keyword like this, and this function can take multiple arguments, right? There is no function name here, just write Lambda keyword. So this takes two arguments, right? X and then y. That's all. Put colon here, just like the way you put. And then what is the expression here? This return x plus y, right? Just write x plus y here. That's it. It will be automatically written because Lambda knows that this is only one liner, and whatever you write here, it has to return. Okay. And what it returned, then you can store in variable add equals to. That's it. So the output of this return, whatever it sums, it gets stored in this. So for your cursor, just reformat the file. Now look at this. Now let's read the definition again. We written a Lambda function in Python. It's anonymous because it does not have any name. The return value is stored in a variable, but that is not a function name, right? It can have multiple arguments. See, I said multiple. You can set 4 also, x comma y comma z, all that. And only one expression. What are you are doing with that arguments that describe everything in one single line in one expression? And that's it. So use it when you need temporarily as a short function, as a one single line. But if you have any complex use of multiple expressions, if condition, multiple lines, then this does not work. You have to go with a traditional normal function. So this will be a famous interview question that asking what is Lambda, and they might ask you to write a syntax of showing that how you can evaluate in one single line. And this is how you can show them as a classic example of how you can convert a normal function to Lambda function. Okay. Now, once you explain them Lambda, now most of them will try to relate that question with a map or filter functions, because that can be done in one single line. Let me show you. They might articulate the example in multiple ways, but I'll explain your concept here. There is a list 1, 2, 4, 5. So what is map function does? First question. The map function can modify all the values present in the list with a new logic. Whatever logic it is, they can modify all the elements present in the list. Okay, so now I am going to change the whole list by multiplying each element with 2. Okay, just multiply them with 2 and print me the list again with updated values. Whenever you get a question like this, what people does generally is they write a for loop, they iterate over the list, and in every iteration they pull out the one item and then they multiply it and they store it in the new list and then they print the list. It is all taking 4 to 5 lines of code. But we can do everything in one single line using Lambda and map. Let's see. Okay, so that's where first they'll check your understanding on Lambda. If you can't even explain what is Lambda, there is no point they drilling down to questions like this, right? Okay, let's start with the way how we define here Lambda, right? And basically it takes each and every item. Let's say it take X, then the evaluation expression is that X, whatever it pulls, it has to multiply by 2. Something like this, you can write a Lambda function, okay? But how you can iterate over each and every value of the list? You written X, but how the X magically will come iterate every time? That's where map comes into picture. There is a function called map, okay, where second argument, if you send a list, pass complete list into that map as a second argument. Now what happens is map will pick the complete list and send each and every index into this Lambda function. It iterates, on every iteration it sends each item from the list into this function, Lambda function. So that means in the first iteration 1 will come here, 1 into 2, right? Next 2 will come, 2 into 2, 4, 3, 6. Like that it will iterate and send every item into list. So that's how our Lambda function is being connected to the list and gets iterated using the function called map. And you can see the map, how it works. In the first argument, it is taking function. Yes, we provided a Lambda function. In the second argument, it is taking iteratable list or anything, right? Object. In this case, list. Okay. So now it does. It multiplies. But whatever it gives output, you see add is where it takes return statement, right? Similarly, whenever it multiplies, it gives back the result. All the result number let's store in one variable. It's all squared numbers, right? Okay, because it multiplied by 2, so we call it as a squared numbers. Now, you want to see it in the output. The way it gives in the raw format. Now, if you want to just get in the list format like this, because that's where your basic interview question is. This is the list provided to you. Now give me the list with the squared numbers. Okay, you got a squared numbers. You know, to make it as a list, just put list of squared numbers. So that will be, converted into a list format, and then you can print it in the output. That's it. Within one single line of code, you have done this. Now let me run this test. Here you go. 2, 4, 6, 8, 10. You see, I know people, when asked, they can easily do this by iterating the loop, multiplying with 2, and then creating a new list. That's whole mess. But if you can explain like this, then that's where you can impress people, right? And obviously you understood how map works. Similarly, there is something called filter. I mean, you might get question in filtered way also. So my question is, give me the even numbers. Okay, now you have squared numbers in place. Once you complete this question, you might get a next question that extract, filter, I want only even numbers from this. Okay, square numbers is this, only pick even numbers and give me the output. But actually all are even numbers. Okay, so how should we do it? Then let's take this array only. Here even numbers are only 2, 4, right? Let's use this. To get even numbers, basically there is another function called filter. So it's not just for even numbers, but filter function, what it does is it filters value based on the condition. Okay, so now I will provide condition that any number divided by 2, if it is 0, then that's even number. I know, right? So using that condition, I can filter out elements. So basically filter function helps into handy that if you have one condition in place using which if you want to filter down the elements in the list. Okay, so now again I'll start with a lambda that it takes x of this numbers list, and then the condition here is x percentile 2. If it is equals to 0, I know that it's an even. Okay, this is my lambda function. So previously, understand the difference between map and filter. Map is that it modifies the elements of the list. It does not filters down based on condition. But filter actually eliminate few things here by applying condition. Okay, so lambda, you applied a logic that you have clearly written that if x percentile 2 equals to 0, then I want those. Fine. But how you will tell that in every iteration you need to pick one by one? For that, obviously you know that there is a filter function just like map. That first argument it takes the function, and the second argument you need to provide which list you want to iterate. That's it. Now this will filter function takes this list and it iterates that every element x equals to 1 will be sent here. 1 percentile 2 is not 0. That will be eliminated. Okay, it won't filter. 2 percentile 2 is 0, it will filter. Again 4 percentile 4 is 0, filtered. 5 percentile 2 0, not filtered. So all the filtered elements are now we have. So if you want them as a list, as I shown, just wrap them into list like this. So list of filtered elements you will get in this variables, and then you can simply print that list. Okay, again without writing any logic of for loop or writing multiple lines of code, I am able to filter down my list. I am able to modify my list based on Lambda and functions like map and filter. This will be very handy guys for interviews. If you can solve something like this, here where you will shine on your experience with Python. Hope this help. How do you sort a list in Python? It's again very simple. Like if you have list in place, now let's say same list, I will rewrite again like num equals to, let's say 3 2 6 1. If you want to sort it, you need not bang your heads by writing any logic. Inbuilt for the list you have something called sorted. Okay, in this function send your list as an argument. That's it, and then you can print it. This will give you a new list completely. So I have seen this one of the question, I think from Cognizant. They have asked, one of the students shared the experience that they want to sort the list. They tried to do a lot of logic in place, but interviewer want that with one single line without spending multiple minutes on that. They just, can you do it in a minute, sort it and give me? You can do that only if you know how the functions are present in list for Python. Okay, so here you go, 1 2 3 6. It just simply sorted out for you. So all this please remember, and you can use this together when you want to solve any complex problems in Python. Is Python asynchronous or synchronous? How many of you know this? By default, Python is synchronous, that it will have a sequential execution, but it also have ability to make async. Okay, so when you get a question that if it is sync or async, then you should say it's both. Now in JavaScript, it's purely asynchronous, right? When you take Java, in the latest versions, yes, they also support asynchronous model. But including Python here, it can be done in synchronous way and it can be done in asynchronous way as well. But for Java and Python, the default programming is synchronous. Okay, now you might have a lot of questions. What is synchronous? What is asynchronous? Let's see with one example. But before we go there, just remember that in synchronous execution, Python executes code line by line in a sequential. Okay, so each operation must complete before the next one starts, which is default, right? That's how it happens when you run. Okay, and that's how Python normally works, unless explicitly you tell that run asynchronously. Now let me quickly show you how default thing work. Now task, a simple function. A function expects an argument, right? Print starting, I would just give the name argument. So at real time what happens is when it prints, the name will fall here dynamically. So starting whatever name you give. So next I will give time dot sleep. I'll just say sleep for 2 seconds before you proceed next. I'll import the time, and then I will again print finished. Okay, so this is Python function. We all know that. So if you want to call this function and run, how will you do that? Simply call the function and then provide task, I would say Rahul, and next task, I would say Shetty. So I'm calling this function twice. First time Rahul will go here and say starting Rahul, it will wait 2 seconds, and then finished Rahul, and then Shetty will start. Starting Shetty, 2 seconds wait and print Shetty. This is normal synchronous is what we are seeing in day-to-day lives. See, starting Rahul, 2 seconds wait, finished Rahul. Now start Shetty, 2 seconds wait, finish Shetty. So the reason I am saying here is, here we are blocking for 2 seconds. In synchronous, yes, it will wait for 2 seconds as you instructor before proceeding. But when you make this code asynchronous, it won't wait. I mean, it will wait, but after 2 seconds, if needed, control will come back, but it will proceed to execute next. Okay. So when it encounter 2 seconds, it will just say one of thread to wait, but it will not stuck there. It will execute other steps. Okay. Now let me show you what happens if you turn this to asynchronous mode. Okay. We just saw that everything is sequence, everything is good. Now same function, I will rewrite here and I will put it async. If you see practical output, then you will understand it better. I made it async. Okay. So here I'll just write like this, await async.sleep. There is asyncio.sleep. If you are writing asynchronous, you can just use asyncio step. Hover your cursor here, import this package. That's it. So you are waiting 2 seconds here. So the reason I am saying is, you are saying keep it as async. That means don't block the control here. You send this request, but continue your execution is what you are saying. All right. Now I'll write one main function here, async def main. 2 tasks I want to execute. Probably, I'll put like this. Just see the statement. Async io.gather task of Rahul, task of Shetty. Okay. I'm asking to gather these 2 tasks into one box, and then I'll just ask to run this main block. Now async everything, whatever you want to run with async, you have to use this keyword async io. That's commonly used. Async io dot run this main function now. Main. I know, we are ending up writing more code, but just follow me, you will understand. So here technically what I am saying is run this function. That's it. Run asynchronously. That's how I am telling. Because if you look at their official documentation, it won't run asynchronously unless you explicitly tell them. Okay. So I'm explicitly telling run this main function asynchronously. Okay. So whenever you are instructing to run any function asynchronously, make sure that function should have async keyword as a prefix. Without having this keyword as prefix, even if you tell to run asynchronously, it won't run. Okay. To make anything to run, mandatory requirement to put async. Great. Okay. So we are running this. What this function is doing? This function is again consolidating, because we don't care about running in sequential. I'm telling you that I'm giving you 2 tasks, run it asynchronously. Same thing, task of Rahul, task of Shetty. Previously everything in sequence, starting Rahul, wait 2 seconds, finish Rahul, and then starting Shetty. Second task will start. Now all the tasks gonna run asynchronously. Now let's see. I'll comment out these steps. So we are seeing the asynchronous run now. Starting Rahul, starting Shetty, and you see the output. It started Rahul. It's saying, okay, you need to wait for 2 seconds. Then task of Rahul is waiting 2 seconds. But again, the next task immediately started. It does not wait task of Rahul to complete until the last step. Okay, first function is being sent, right? First function is in wait mode. Then if it is synchronous, it will wait until first function is completely done before second function get triggers. But now we are running in asynchronous mode. when first function is in progress, somewhere blocked, second function also it starts immediately. It won't wait that to complete. So that's why starting Rahul, when it is waiting 2 seconds, immediately second task also begins starting Shetty. Okay, the moment it comes down to this step, the 2 seconds is complete, and then first task got executed again, and then second task followed. So like this, all tasks will run at a time. And if there is any block, one will not wait for another task to trigger. See, theoretically, we are saying to run in sequential only. When you run, this will run first and this will run next. But somehow, for any reason, if this is in blocked mode, then control will immediately go to the second one. And once the blocked mode is done, and it will resume the execution. But it won't wait there. That is the difference between synchronous and asynchronous. Now here, it will wait. Though there is next step to run, it will wait, but it does not wait. So where it is required, this is required especially when you have multiple tasks to run concurrently. Now when you load a page, if there is any table records, the table records will keep on loading. But top header will get loaded, footer will load, right side images, everything will be there. But middle one will still sync to load. So that means there is asynchronous applied there, where whole page components are loaded instead of waiting for one component to show up. Okay, let it show when it is ready, but remaining all will show up, right? That's where asynchronous will really help in the development. Overall, so this is how you need to answer. Python is synchronous and asynchronous. Until unless you told, it will run in synchronous. If you want to explicitly tell, make sure that every function have async keyword as a prefix, and when you are calling the function, then you can only call with asyncio dot. That is important to call any function asynchronously. As long as you've taken care of these keywords, things will change into asynchronous mode, right? Why self convention used in Python? Explain with example. We have already partially seen this explanation in one of the example before. So basically, self, this is not a keyword, but it's a convention in Python. So that refers to current instance of class. So that means if you have a class like this, for a whole class, it's an instance. Okay. So if you have methods in class, that self keyword by default will be your first parameter. So nowhere you will see a method of class without a self keyword like this. It is mandatory for you to write self terminology here. Why? Because self here is an instance. So you can attach anything to the self instance, so that way you can access it anywhere inside the class. We have seen one classic example before. Again, the similar thing we have here, that when you create an object of this class, by default constructor will be called. So here we are declaring parameterized constructor. So that means we are calling the constructor with 2 arguments, and we are sending Alice and 30. So technically name and age will be available for access inside this block only, but I need them to access in my method. But the scope of those variables will be inside this. Once you come out of those, this will show as null pointer. Here where self comes into a picture. So self is available for every method, to constructors as well as class methods. Using self, we will attach it. The name and age what we got from your test, we will attach to our class instance called self. Because you attach to this here, this self.name you can use anywhere in your class. So because we got there, now I am using it in my method. So it's nothing but same alias as we have assigned it here. So that is how self will help you to travel all your variables across anywhere within your class. Even you can call methods also. Now, if you want to call your own method here, you can do that as well. So let me just show here. You can put another one, self dot greet. You can call your own method, because that's still part of your class, right? Any class instance, variables, methods, everything you can just call like this. Self.greet will call your own class method. Fine. What if you call super.greet? Okay, so that means super will refer to its parent class, right? But unfortunately, this class is not inheriting anything. So there is no parent for this. So there is no sense in writing super.greet. So previously we have seen one example like Here we have parent, and when you say super.greet, it will call parent class method. But here, if you say self.greet, it will call its own class method. See, do remember all these differences. Super, whereas super is used, whereas self is used. Okay. And in Java, as I said previously, they have something called this keyword, but Python does not have any this keyword explicitly. Instead, they call it as a self to access instance variables, methods within your own class. And do remember that it must be the first parameter in all the class methods and the constructor, right? So that's how self work in Python. How do you reverse the elements of a list? I particularly added this interview question because people solve it for sure, but they end up writing a lot of code, writing a for loop, start from the reverse index, store again the stuff into list, right? But there is one simple line. You can just reverse the elements just like that. Let me show you. Number equals to 3261, right? Now, if you want to print it in the reverse, it's very simple, guys. This is your list, right? Put 2 colons, sorry, and then put -1 index. That's it. Whole list will be printed in the reverse. That's the magic and a tip you have within the Python list, right? And if you can show this way to your interviewer instead of writing a for loop, taking 5-10 minutes time in reversing, yeah, people do it for sure, but show me this way, and I'm sure that anybody can impress, right? Now, when you run this, it will print as 1623. Here it is. Okay, this is sorted order, but this is how you can reverse it, right? Just 2 colons and -1, the entire number stuff will be reversed. Great, right? So I hope, especially this file, you need to remember, because when you download Codebase, make sure you recall all this before you sit for Python interview. So what is the difference between class method and instance methods? We just discussed about how self keyword plays a main role with the instance variables transfer, right? So now let me show you another example. You are familiar with this, right? Class. And you are also familiar with the class method. And we know that self keyword is the first argument, right? And now how you create object for this class? My class and obj. Now object dot, you can call this method instance method. Everything is good. Now there is something called class method. So this method can be accessed without creating object. Okay, so this is independent of the class instance. So that means self is basically acts as an instance for your class, right? But this method does not belong to the class object instance. It is just a class method on class level. So that means without even calling or creating object, you can directly call this class with a class name itself. See, now if you want to call this instance methods, you have to mandatorily create object of that class, and with that object you will call this method. That's how we have seen until now. That is some normal fashion. But if you have annotated with class method, right, let's say there is some requirement that you need to access them directly, even including without creating objects, because you are very clear that you are not sending any values, parameters to initialize constructor, or you are not using any instance variables. Okay, so if you are clear on that, and if your class just does things on its own without relying on any self keyword or any parameters of sending like this from object, then simply you can put class method annotation to it. You need not have self as first argument, but here class will take as a first argument, CLS. Okay, so now without even creating this, now I'll comment out this object creation. No need. You have a class like this. As long as that method is annotated with class method, you can use that class name and call it. Okay, so you can save the time. So when you run it, okay, it does not have any print. So okay, you have it here, right? We are printing in the output. Let me run this quick. So you will see output as class. See, so that's how you can still call methods. But you know, the way the question of interview might be different. Is there any way I can call methods of class without creating object of that class? Question could be framed in this way. Instead of directly not asking difference between class and instance, then you should say, yes, it's possible if you annotate that method with class method annotation. And you should also tell them that a precaution that when you are annotating any method with class method, that means you don't have access to this self instance variable. So if you are sending any values for object creation, then there is no point in annotating with that method with class. That won't help. How will you get access to those instance values what you are sending at runtime? That's only possible with self keyword. If you want to put self keyword, that should be instance method. That cannot be class method. As long as your method is independent of any parameters sending as a runtime, it's just a static code. Then why not just use class method annotation and call it directly with class name dot instead of being headache of object. That's how you need to articulate your answer. So what is use of conftest Python file in Pytest framework? Again, this is very, very important question, guys. If you are attending for any test automation interviews, Pytest will be obviously thing people will ask. In the Pytest, conftest.py file. This is very important file because this is a place where you can define all your fixtures and test hooks. Okay, so what is the special of declaring in this file? If you declare in this file, then this file will have automatic access to all test files present in that folder. Now let's say this is one folder, right? All files are there. Put conftest file here and all these files will have access to that conftest. So that means now you have a fixture here. Where did we see that? Here, right? So this is your test. Okay. Now you have declared that fixture here, that whenever you send fixture as an argument, it will check where that fixture is, right, in your own file. But if it is not present here, it will still try to search. Where is it next search? It will search in the conftest.py file. When it could not find that sample data fixture in your own test file, then it will immediately search for this conftest.py file. If you declare that fixture in conftest.py file, it still picks from there and loads at runtime. So it's like heart of your Pytest project, because that's one centralized file where you can declare all commonly reusable fixtures and all test hooks. That way you can eliminate of having fixtures in your own test file and isolate them from your core logic. But do remember that use your fixtures in conftest file only when you think that fixture is required for multiple test files. Okay, if that fixture is specific to your own test, then it does not make much sense of writing there. So write it there when it need globally across multiple test files. Okay, so that's where conftest.py plays a role. It's just another Python file, but the moment you change that convention of this name conftest, Pytest will be activated to have it search and get the files at runtime. Okay, do remember this. Another quick interview question: how do you execute only failed tests in Pytest? Very simple. After test execution is complete, rerun the tests with this command pytest -- last failed. So it can pick its last report and pick up all the failed tests and it reruns it. So most of the people will get confused when you get a question that how do you execute only failed. Okay, they try to combine this question with tags answer. Okay, tags are something which you will see the next question. So this is just to pick only failed tests. So how it is internally happening, that means whenever you run your Pytest, the common report will get generated. So this command will go to that report and picks up that failed test and it will just trigger only those by just giving this flag -- last - failed. So that's how you can still run your failed test in Pytest. Next, this is what I'm talking about. how do you apply custom marker to test case in Pytest? Now let's say you have 100 tests and you want to mark some tests as a sanity. So that way you can run only those tests which are marked as a smoke, sanity or regression. Okay. So for that, you already have tests in place here, right? Assume that this is one test. All you need to do is just add this annotation that when you mark your test with sanity, now let's say you have a lot of tests here, but when you are running that, just put -m tag. M stands for mark, and just put sanity. That's it. So instead of running all tests, it will look for tests which are marked with sanity. So that means it will look for tests which have annotation of mark.sanity. Only those will be picked. So this is very important when you are working with test automation frameworks. Every time you won't run all the tests, right? Sometimes you run only mobile tests, regression tests, smoke tests to test the build, sanity tests. So like that, you have segregation with the help of mark dot, giving that keyword, and just run them -m and that mark name. So that's how you can apply custom marker and control your test execution in Pytest. So what is Python with statement? So carefully, if you can recall, we have seen this with statement previously. When if you want to read any file or write to any file, we have used an open function there where we have used a with keyword. Okay, so with statement is used basically for exception handling. That's the primary use. Or you can also use for creating or managing resources, like creating a file. You know, you are managing a resource there. File is a resource. You are managing it by creating it, by editing it, by saving it, right? You can use for those as well. And especially for exceptions, file creations, and finally blocks. Wherever these are applicable, then you will use a with statement there. Okay. So one simple example, we have already seen how this is used, because this is a resource, right? File is a resource for me. As long as you are dealing with a resource like a file, Excel files, and any databases, wherever there is a concept of resources which you want to read, write, manipulate, or exception handling, for those all scenarios you use with a with statement in Python. Okay. And if they ask any example, just show them this read write statement, and I'm sure those people will be convinced. Okay. Now, to continue to this interview question, when you say that with statement is used for exception handling, then your next question will be like, okay, tell me how do you handle exceptions in Python, and where this finally keyword is used, because you used those terminologies in your previous question in describing with statement, right? Now let's see a quick example of how to handle these exceptions. Now, same test previously we have written to write and read into file. So now, what if file does not exist for you to read at all? Okay, somehow you need to handle that exception and print nicely in the output. But in this case, try block. Okay, so if your ultimate goal is that, you know, if you don't want to have weird error and show proper error in the output on how to catch exception, now this is how we can write. I am fixing the conventions here. So you write it in try block. So that means if something is wrong in this, test will not fail, but it will come to except block. Okay. If you don't have this try catch mechanism, test will simply fail. If your goal is to not fail and tell an output properly logging that file is not present, then you can catch that exception. So when you try to execute this, the Python first will try to open a file which does not exist at all, and immediately it comes to the except block to handle this exception. So here where you will handle except file not found error. If you see something like this, catch that exception and print it in the output, that exception what it is fully, that in the output log you can print it. So like that, instead of failing, you are continuing your execution but tracking that error report like this. Okay, so these exceptions are usually used for resources opening, or not just that, if you have any math error 4 divided by 0, that you can catch as another exception called zero division error. Okay, so if you don't exactly know what kind of exception it is, you can write generic exception also. This is generic class, it can accept any kind of exception. Okay, so it could be related to file, it could be related to memory exception, arithmetic exception, whatever it is. Exception is a main class which accepts any kind of exception and it prints you in the output. But good thing here is, instead of terminating the program abruptly here, test will come to the except block and it will nicely log the error why exactly things are failing. Okay, so you will have a better output understanding on what is happening if you handle with try except block. So if it found the file, it does not execute at all. Okay, so we are wrapping it in try block, saying that only if there is anything wrong within this, then only the control will come to this except block. If it is good, as long as everything goes well, the file is there, read content, all good, then it will never execute. It will just continue with line number 13 after line number 8. Okay, so like this, there is another keyword called finally. So this is interesting. No matter test failed and come to this block, or test successfully ran and skip this block, doesn't matter. When you have something called finally keyword, this will execute by default irrespective of your result, that is it going to accept block or not. So this is the place where you can use to close database connections, right, and clean up any resources. You can write all the stuff in the finally block, because the execution of this block is guaranteed as long as you wrap it in finally block. Okay, so execution of this block except is not guaranteed. It comes into this only if there is something wrong in your try block. Okay, so let's say if there is something wrong, it comes into this, it will still execute, and if nothing is wrong, it will still execute. So that's why use this block particularly when you want to close all connections, clean up resources irrespective of how your output is. Okay, and you understood why we are using with keyword, right? Because to handle the resources and manage it, all comes together as a package with exceptions, where finally, catch, try, except. Okay, so that's it. With this, we are wrapping up the most commonly asked Python interview questions. We have covered various things starting from data types, object-oriented principles, asynchronous, synchronous, and special functions like gamma, filter, map, and then we have also seen exceptions. I think this pretty much covers most of the concepts, and you might get different questions like sorting and reverse, all that, but from the concepts what we learned, you will be able to solve. Okay, we have seen some tips also within list data type, and no matter how the questions are framed, with the depth of concepts what we understood with practical examples in all these 10 concepts, I hope you will be able to answer 80% of Python interview questions from this video. This is your instructor Rahul Shetty signing off.